Advanced Algebra Chapter 7, Lesson 7, and we want to wrap this lesson up by looking at composing inverse functions. Now, we looked at composing functions, and you remember when we compose functions, we take the output of a function and then use that as the input into a second function. And we can either do that by evaluating the function first with a value for the variable, simplifying to a number, and then taking that number and substituting it into the second equation or the second function, and that gives us the composed value. Or we could take the entire function and substitute it into the second function and then evaluate the result. When we do that with inverse functions, something interesting happens, so we want to take a look at that. If we are doing this composing with f and f inverse, and they both are functions, then the inverse must map b onto a if f maps a onto b. What does that mean? Okay, here's what it means. If you take a and you substitute it into the inverse, it produces b, and then if you substitute b into the function, it produces a. So basically what happens when you compose an inverse with its or a relation with its inverse, and they're both functions, whatever you put in, that produces an output. You take that output, put it in, it's going to produce the input. What? That's what I thought. If you put a in, it produces b. You take b then and put it into the second function, it produces a. So whatever you put in the first function, when you compose it, it ends up being what you get out. What? Okay, let's just do it this way. If f and f inverse are functions, they're called inverse functions, and therefore if you compose the function with its inverse, you're going to get this x. Or if you compose the inverse of this function, you're also going to get x. So it doesn't matter what you're going to do, you're always going to get the same function. So when you compose a function with its inverse, you end up with the exact same value. Okay? What? Okay, that's the third time you said what, so I think maybe I can do this better by just showing you an example. Look, if you compose the inverse with a function, okay, if you put in 10, you're going to get out 10. Ta-da! Whatever you put in, that's what comes out. You don't have to put it into here. You don't have to go through the whole process of finding the inverse. You just understand that if you put in 10, you're going to get out 10. Okay, it's that easy. Alright, so if these are inverse functions, if you put in negative 10, what are you going to get out? Negative 10. It's that quick. Okay? If you put in 0.2 and you're composing an inverse function with its inverse, or a function with its inverse, what are you going to get? 0.2. If you put in d, you're going to get d. Alright? So that's all we're going to do with that. Okay? It's that easy. What? Yeah, it's that easy. Okay? It's that easy. Whatever you put in, that comes out. If you compose an inverse with its original relation, and they both happen to be functions, then whatever you put in, that's what comes out. Doesn't matter what the function is, doesn't matter what you're putting in, it just doesn't matter. What you put in, that's what comes out. Okay? So I think that's a little bit, I think that's really easy, and so I'm not going to talk any more about it. I'm just going to end this video, and that's going to end Chapter 7, Lesson 7.